The multiple lines we draw on a plane or on a piece of paper may cross or not cross at all. If they do not cross, lines are said to be parallel. If they cross, they will form four angles. When the four angles are equal, they measure 90 degrees each. Lines that cross at 90 degrees are said to be perpendicular. This is the symbol for perpendicularity. The way to tell if two equations represent lines that are parallel or perpendicular is by the slope. If the slopes of two or more lines are equal, the lines must be parallel. In these lines, the slopes are the same and the distance between them is always the same. If, on the other hand, the slopes are not equal, it means the lines cross like this. If the line crosses at 90 degrees, then the slopes are reciprocal and opposite of each other. This is important. Let's see what reciprocal and opposite means. A reciprocal is a rational number that is written upside down. The reciprocal of 3 over 4 is 4 over 3. The reciprocal of 3 over 1 is 1 over 3. The reciprocal of 1 over 2 is 2 over 1, or 2. The opposite of a number is the number with the sign changed. The opposite of 4 is negative 4. The opposite of negative 1 over 5 is positive 1 over 5. Therefore, the reciprocal and opposite of 1 over 4 is negative 4 over 1, or negative 4. The reciprocal opposite of negative 5 over 4 is 4 over 5. Because 1 over 1 equals 1, the reciprocal opposite of 1 is negative 1. For example, our lines represented by equations y equals 2x minus 7 and x plus 2y equals 5. Are they parallel, perpendicular, or neither of the two? By looking at the first equation, we can identify the slope as the coefficient of x. Therefore, the slope of the first equation, y equals 2x minus 7, is 2. Now we write the second equation in y-intercept form by subtracting x from both sides and dividing both sides by 2. This yields the y-intercept equation y equals negative 1/2 x plus 5 over 2. The slope of the second line is negative 1 over 2. Because the slopes of line y equals 2x minus 7 and y equals negative 1/2 x plus 5 over 2 are reciprocal and opposites, the lines are perpendicular. Another example. Are the lines represented by equations 3x minus 2y equals 14 and 2x minus 3y equals negative 15, are they parallel, perpendicular, or neither of the two? Turn first equation into y-intercept form. Subtract 3x from both sides. Divide the equation by negative 2. Same signs, positive. The slope of the first line is 3 over 2. Now turn second equation into y-intercept form. Subtract both sides by 2x. Divide equation by negative 3. The slope is 2 over 3. Because the slopes 3 over 2 and 2 over 3 are neither equal nor reciprocal opposites, the lines cross, but they are not perpendicular. One last example. Are the lines represented by equations y equals x minus 6 and 3x minus 3y equals 11, are they parallel, perpendicular, or neither of the two? The slope of the first equation taken from the coefficient of x is 1. Turning the second equation into y-intercept form, subtract 3x. Divide whole equation by negative 3. The slope is 1. Because the slopes 1 and 1 are equal, the lines are parallel.